A former senior vice president of Eli Lilly and Company said that it's given that statistics graduates will come in with a deep technical expertise. In addition to that, what is important? Okay, in other words, statistics graduates should come in knowing how to do statistics. What's important? First and foremost, I'm going to talk about communication. Communication, communication, communication. If you can do math or statistics in a job, but you can't explain what you're doing to someone else, particularly someone who doesn't have the technical expertise that you have, and explain it in a way that's understandable in layman's terms, you are not going to go very far in that career. So you need to be able to verbally and in writing have good communication skills when it comes to statistics. So that's what we're going to be talking about next. Oops. Sorry, I wanted to delete that so you didn't see what was on there already. Okay, so we talked about the 4 characteristics that we need to compare. We need to compare shape, center, spread or variability, and outliers. So we're going to talk about the vocabulary that we need to use to do that. Shape has 2 characteristics. The number of peaks in the data. One main peak means unimodal. So this would be like the golf scores that we talked about. 2 main peaks, bimodal. Something like this. Later on we're going to look at something having to do with lawyers that is bimodal. Uniform means basically straight across. An example of a uniform distribution would be if you rolled a die over and over and over many times, and you would expect the number of 1s, 2s, 3s, 4s, 5s, and 6s to be approximately the same. But they're going to vary a little bit, maybe, but pretty much straight across as far as the shape, because that's called a uniform distribution. Now, think about when we talk about number of peaks that we want to use the big picture. So if I go back and look at, say, the golf scores, or look at some other, actually we'll go back to the previous page and look at some of these. When we see these distributions, we see that there are kind of some ups and downs here in these peaks, you know, that it kind of goes up, it goes down, it goes up again. But big picture, all of these have one major peak. Like the data itself has one major peak. So we're not going to count all these little bitty jagged things as different peaks. We're talking about big picture. The second thing is, especially if it is unimodal, then we want to go on and say whether it's symmetric, skewed left, or skewed right. So symmetry, symmetric, same on both sides. Skewed to the left means that most of the data is on the right, but the tail goes to the left, okay? Skewed right, the tail goes to the right. The second thing, so there's shape, that's the first thing we want to talk about. The second thing we want to talk about is center, which is the approximate middle of the data. Now when you're looking at a graph and you're trying to talk about the middle of the data, remember that you are going to just have to estimate. You're not going to count it all up. You're going to look at it, kind of stand back from it and go, oh, okay, I think the average is about this, or the middle value is about this. So big picture. Later on we'll learn a couple that there's 2 specific types of centers we talk about, the median and the mean. So sometimes you'll use one and sometimes you'll use the other. Spread is we're talking about variability in the data. So maybe variability from the center, maybe variability from low to high. So either one. Variability from the center we'll talk more about that. Sometimes it's called standard deviation, sometimes it's called IQR. Variability from low to high is called range. Range equals the maximum minus the minimum. So that's a good number to use. You could also just say, when you're talking about spread, that the lowest value is such and such and the highest value is such and such. That would be a way to talk about spread. Outliers are departures from the overall pattern. So they could be one individual that is way far away from the others. It could be a clump of data, two separate clumps of data with a gap in between. So we're looking for outliers. So we could have individuals or clusters, and individuals or clusters and gaps of outliers. You want to give the specific location. So if you're saying, oh, there's an outlier in the data, you don't want to just say that. You want to say, there's an outlier. There was one particular golf score that was extremely high at about 126 strokes. Whenever you describe and compare, you want to do it in context. I cannot stress that enough, because we're not just talking about graphs and sets of numbers. We're talking about, what do the data mean? And if you think that I use poor grammar there, data or data is a plural word. So what do the data mean is accurate. Now notice that we have shape, center, spread, and outliers. And that's usually the order that I like to talk about them when I'm writing a paragraph about a graph. I like to start out with shape, then center, then spread, then outliers. But we have an acronym, SOCS, that helps you to remember the two S words, shape and spread. The O is the outliers, the C is the center. So if you're trying to remember those four things, that's a good acronym to help you remember. Let's look at a couple of examples where I have written out a sample description comparing three different distributions. So when we're comparing, we want to talk about the characteristics that are significant when comparing the data values. We want to use comparison words. We want to talk about how things are similar and how things are different. And we also want to use what I call weasel words. And I think I forgot to write these up here. So let me take this little thing off here, and we want to use weasel words. Weasel words are words like about, or approximately, or similar. Okay, things like that, because not similar, those are comparison words. Proud, or approximately, or fairly. Okay, because we might say this data is fairly unimodal and symmetric, or we might say that the center is about 23 inches or something like that, because you can't tell exactly from looking at the graph. So we want to use those words. So when we read this, these are three classes and the test scores. So I notice here that the data big picture is fairly unimodal and symmetric for all three graphs. Now there are three looks like three sort of separate peaks here, but I'm still going to go with big picture. I'm thinking this is still basically unimodal. If there were more data, it would probably kind of fill in and smooth out. If I did a lot more data and I still saw those three peaks becoming more distinct, then maybe I would go and say, oh, there might be three separate groups here. But right now, unimodal and symmetric, big picture. Notice that all graphs must have the same scale. When you're comparing them, it doesn't do any good to compare them if they're on different scales. So we have them all on the same scale. So I say the distribution of scores. Notice I didn't say the graph or the data, but I use context here. So the distribution of scores for all three classes are approximately unimodal and symmetric. So notice here's my weasel word, and then I'm talking about shape. So usually I start out with the context and talking about shape. And then I go into either center or spread and talk about that. So since the spreads are about the same, that's what I'm talking about next. So the distribution of all three classes are approximately unimodal and symmetric with a range of about 40 points. That means from the lowest value to the highest value of the test score, there's a difference of about 40 points. So I'm talking about spread here. Now the reason I did spread second was because spread and shape were similar for these three graphs. Now I'm going to talk about the difference, which is the center. Class A appears to have done better all. So notice I'm comparing. I'm saying that Class A is better than the other two classes, with an average score of 82 points compared to Class B with about a 72-point average and C with about 62 points. Notice I'm supporting my comparisons with specific numbers. I don't want to do what's called a laundry list and just say, Class A looks like this, blah, blah, blah. Class B looks like this, blah, blah, blah. Class C looks like this, blah, 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 without actually comparing them. That is not helpful. Now let's look at Class D. Here we have symmetry, fairly unimodal and symmetric for all three. This one's maybe a little bit skewed to the left, but fairly symmetric. You can kind of go either way with that. But the centers are all pretty much the same. The main difference is the amount of variability. So here the scores are much more consistent than in Class D than in Class E or F. So here I'm just going to go through the distribution of test scores. Context for all three classes. All right, there's my context, is unimodal and fairly symmetric. Shape. Notice I have fairly, they're not very completely symmetric. And I could maybe even say fairly unimodal. And all three classes scored an average of about 70 points, not exactly, but about. Class F scores vary much more widely than the scores of E and D. There's my comparison there. And actually my comparison here is when I say all three classes were scored this, that they're the same. Okay. I also put there are a few outliers, but none are extreme. I didn't mention outliers in the first one because there really weren't any. So if there aren't any outliers, you can leave that one off. You might want to talk about this as an outlier, but if it's not really far away from the general trend of the data, then I usually don't mention it. This one maybe, but once again, the data is really spread out on both sides, so this isn't a real departure from the overall pattern. Let me get back to what I was reading. Okay, Class F scores vary much more widely than the scores of E and D with a range of about 60 points as opposed to about 40 points for E and about 20 points for F. You could also say that Class D has the most consistent scores, which is another way to describe spread. So these are some examples of the way to write and use those four characteristics in context to describe and to compare three groups of data. Now this video is getting a little bit long, so I'm going to go ahead and show you the notes with the words already filled in and just kind of go through this and talk about it a little bit, and you can pause this to fill this in. When you are comparing two distributions, there's some important things to remember. Graphs must use the same scales on both axes. If you are dealing with unlike group sizes, you must use percents and not counts, relative frequency instead of frequency. When you're asked to compare, use specific comparison words, similar to, more than, less than, approximately equal. Do not just make what I call a laundry list of characteristics for each graph separately without comparing. Support your comparisons with specific numbers from the data. If you say this means greater than this other mean, then tell what the means are, or what they approximately are. Use context. Don't just say the graph is, or the data are. Actually, are is plural. But make the data tell a story. Tell what it's about. Use weasel words. About, approximately, tends to, fairly, close to, those kind of things. Because we don't know exactly what things are, so we don't want to be really precise with our language when we can't be precise with our description. Okay, now here's an example of a bimodal graph. So this is very distinctly bimodal. This is the distribution of starting salaries of lawyers who graduated in 2014. There were some self-reported 22,095 salaries for full-time jobs lasting a year or more. And so this is a bimodal distribution. When I'm looking at a bimodal distribution, I want to describe the center and spread of each peak separately, because describing the center of the overall graph really doesn't tell you much of anything. Okay, you've got you know, the center here, the mean is $82,000, but very few lawyers actually made around $82,000. There's a clump here where we could say there is a large group of lawyers who made between about $25,000 to maybe $90,000 a year, with the average of that group being about $55,000 to $65,000 or $65,000 to $60,000 a year. Then there was one extremely large group that made about $160,000 a year, and not a whole lot in between. There were a few more high, so we can say this graph is kind of skewed to the right, but there's this unusual peak here. So one thing, when we have something unusual like that, you might want to think, why? Why would there be this big unusual peak? Well, these lawyers are probably the public defenders, those who are hired by the state, maybe some lawyers who start their own practice, and they start off with, not a lot of income. Or these lawyers are probably the very small, this is kind of a small group of lawyers. I mean, compared to this, even though this is one large peak, this is a lot more lawyers over in the rest of the graph. But these lawyers are probably, this is probably the starting salary for prestigious partnerships law firms. You probably have to, go to an Ivy League school, know somebody and that kind of thing to get those jobs as a new lawyer or something higher.